We're going to talk about the power, or how do we distill, LLMs and smaller LLMs to get really high accuracy at the same time, like cost effective, right? So this is the agenda. So the first step, we're going to talk about what is the challenge of using larger LLMs in production setting, and why do we have to think about like other alternatives like distillation. So we're going to talk about also what does it mean, like what's the definition of model distillation and how it works, what are the different types of distillations. So we're going to cover 3 different types. We're going to talk about the specific use case, and then we're going to do a quick demo on how to do it actually in real application. So if you look at the current trend, right? So with GPT's models and like GPT 4.5, GPT 4, all of these models, they gain more capabilities as they get larger. So the bigger the LLM, the more complex it is, and the the more capable it is, because it has these complex connections where it can increase accuracy on many multiple tasks. And this trend has been true for quite a while. So bigger LLMs are generally better. So the bigger they are, the better they are. Even with this test compute time that has been developed recently, with bigger LLM, the reasoning capability is better. So that's a given. However, bigger LLMs are great at zero-shot and few-shot learning on many tasks, like reasoning tasks, classification, math, and so on. However, the bigger they become, the higher the cost it is. So as you can see here, if you use like GPT 4.5 or 4, you need to, or even like a Claude, you need to pay like for each request quite of an expensive, costly request, basically. And also the latency. So if your application requires like really short latency time and very fast response time, bigger LLM might not be suitable for that, because they will take like longer time to respond. And there was also a recent study where bigger LLM, because of their complexity and the size of the model, they are actually harder to align on specific tasks, and they are more prone to overfitting actually. So, and there's this concept of catastrophic forgetting, where basically if you fine-tuned on a smaller data set, it might actually forget other capabilities it has. So bigger LLMs are good on like many tasks, but when you want to have a specific task that you care about, it might not be the best option. So this becomes problematic in production setting, right? So imagine you have, for example, a specific task like creating emails or like analyzing contracts, and you want to basically analyze millions of contracts and at a very like short response time. Bigger LLMs actually are not suitable for that. So the question then becomes: is it possible to make smaller LLMs as intelligent as bigger LLMs, but on specific tasks? Like I said, like content, email generation, or content, or contract analysis or information extraction from invoices or whatever. Is it possible to make these smaller LLMs as capable as the bigger ones on specific tasks? So that's the question. And this is where distillation comes in. So basically, the concept of distillation is the following. So the idea is you start with a bigger LLM, like in this case, let's say it's like GPT 4.5 or a Claude or like a DeepSeek model that was recently developed. And then what you do is you elicit information from that teacher model. So you extract information for a specific task. So let's say, for example, what I care about is I would like to analyze, news headline and extract, a JSON file with all the entities and relationship between the organization or entities in the news headline. And I want it to be super accurate. So what you do is you prompt this LLM to extract, to output. So you prompt it with a specific prompt that you care about, and you output, you get the output. So you have the pair of input an output pair, so from this bigger model. And you do that multiple times. So you collect this synthetic data, we call that the training data, and you do that multiple times. And then after that, after you collect this data from the bigger model, you can actually feed that data to the student model. So this could be, a llama, 8 billion parameter or 2 billion parameter. So the idea is you collect this really high quality data set from the bigger model on a specific task that could be coding, chain of thoughts, like reasoning steps, mathematical problems, text to SQL, whatever you need, basically. So you collect all the data set, and then you feed that data set to the smaller model, which is like, as I said, 2 billion or 8 billion parameter. And the goal is to basically, the student model will learn the knowledge from the bigger model and will be as good as the bigger model on that specific task. So are there any examples of successful LLM distillation? Yes, there is. And this is a great example from NVIDIA. And I really recommend everybody to really take a look at this paper. So what they did is they started with a bigger model. It's called Nemotron 4. This is a 15 billion parameter model. It's not huge, but still like considerably big. And what they did is they distilled knowledge from this bigger model. So they extracted knowledge on math, coding, philosophy, multiple tasks, basically. And what they did is they fine-tuned a smaller model, like an 8 billion parameter. They call it Minitron. And what they found was this 8 billion parameters is almost as good as the bigger model. As you can see, this is the score on the y-axis. But what's very surprising here is this data point here. So what they did is they took a same size model, they called Nemotron 8 billion parameter, and they trained it from scratch. So they didn't do any distillation. They just fed it a lot of data, trillions of tokens, and they trained it from scratch. And they compared the performance of this model trained from scratch compared to the distilled model. And surprisingly, the model trained from scratch was less accurate than the distilled model. So what this means is, given the same size of the model, distillation from a more intelligent, capable model is actually more powerful and provide more accurate performance or higher performance than the same size of model trained from scratch. And this is like resulted in almost like 40x cheaper model, and also 9% better. So it requires less data to train distilled data, and also it's better than the model trained from scratch. That means the intelligence that we gather from or the reasoning or the knowledge that we get from the bigger model is actually more beneficial than training a smaller model on like a lot of data. And this is really the key, is you can, by distilling knowledge from a bigger model, you get really high quality data set that makes you can get really high performance doing that. And they did the same thing with the 4 billion parameter model. So they took the 8 billion and then they distilled the knowledge from the 8 billion to the 4 billion. And that's the 4 billion is even more performant than the 8 billion from scratch. And this is really kind of surprising, is like distillation is not just creating synthetic data, it's creating really high quality reasoning data that makes the model much more smarter than like training from scratch. So this is really the key where LLM distillation is basically provides you with this tool that you can create really high performant smaller models with. So and there are many examples, like there are DeepSeek, for example, models. It has been, I think, shown or like suspected that they distilled like GPT-4 models to create DeepSeek, like a really high performance model, plus few tricks. But there are multiple actually examples of successful LLM distillation. So what are the different types of LLM distillation? The first type is information extraction. So let's say you would like to extract information very accurately from your document. That this could be like a contract or a financial statement, or an invoice. And the smaller model will struggle with that because it has it's like 2 billion parameter, for example, or 8 or like 5 billion or whatever. So what you do is you extract the labels from the bigger model, like the larger LLM, and then you take those labels and then you train a smaller model with it. So that's information extraction. The second one is text generation. So it's the same idea. So basically, you extract, reasoning steps from the bigger model, and then or like summarization or like text to SQL or any text completion task, and then you feed that to the smaller model to train it on. And finally, reinforcement learning. And here the idea is, instead of doing supervised fine-tuning, so getting all the data set, so we reverse the order here. So we basically take the output of the smaller model. So there could be like multiple outputs per prompt. And then you rank basically the output using the bigger model. So we call this direct preference optimization. So you rank the outputs like based on the bigger model like preference. And so those are the different type of distillation. And this is a small diagram basically showing the steps. So for the first one, for information extraction, you upload your data. So this is your unlabeled data set. This could be your PDFs, your images, your like invoice, financial statements. You let the LLM teacher label the data. So this could be like a Gemini model or a GPT model. You collect this data set, and then you do supervised fine tuning on the student. So you train the student. For the second type, same idea. So you do zero shot, few shot of the LLM teacher on a specific task, and then you train the student with it. And this is the reinforcement learning. So the student here, we reverse the order. The student generates the output. So let's say you want the student, the smaller model, to generate like highly engaging emails. And so you ask it, please generate 4 variants of that emails. And then it will generate like 4 outputs. And then the LLM teacher is going to rank these outputs, good or bad, or like with the different scores. And then you take that ranking data, and then you feed that to the student model, and then you train it, you reinforce it on those preference data. And then you redo that. So you do that multiple times. And this is the idea of like reinforcement learning via the teacher feedback. So these are the 3 different types so far in LLM distillation. I think there are a few other ones, but I covered the main ones. So how do we get that done? So basically, our platform. So we at UBI we make this entire process more streamlined. So you can basically generate this data, the synthetic data or distilled data, with few clicks. So you can basically do data generation, first step, and after that you can basically fine tune the model using that data collected, whether from distillation or from human labeling or human feedback. And finally, you can deploy these models in production, and then evaluate them, and then trace them and make sure that they are behaving correctly. So the kind of the advantage of this entire process is you end up with really high accurate models. So you can boost accuracy by distilling, a small like a data set from a bigger model. So you can make your small model more high accurate. It's cost effective. So instead of like 15 cents per like million token or something, it would be like 0.0001 cents per like million token, for example. And so basically that makes like the entire overall the cost much cheaper. And finally, most importantly, is you can these models that you train and with like distillation, you can basically run them locally. So you can download the model and then run those into your application locally. So this could be your even like your own server or like a phone. So you can basically run them locally. You don't have to rely on like a third-party cloud provider. So these are the 3 kind of advantages of doing this process of like distillation and fine-tuning, basically. So right now we're gonna move to the demo. So we're gonna show here a few use cases of fine-tuning and distillation. The first use case I'm going to show is on documents. So this is the first, the first type of distillation, which is information extraction from documents. So we're going to show how to do that in the platform. So if you move to the platform here quickly, okay, so let's go here. So this is the UBI platform, and it's you can access it for free, so you can create an account and access it. But basically, the idea is you can fine-tune different models. These are from like few million parameters models all the way to like much bigger 70 billion parameter models. You can fine-tune on our platform. So the first case I'm going to show right now is information extraction from bank statements. So I'm going to go to this data set that I already uploaded. I'll show you how it works. Okay, so the idea here is we have bank statements, and we would like to train a smaller model on identifying specific entities from the bank statements. And so basically, in this case, I uploaded only 39 pages, 39 bank statements. This is publicly available data set. But the idea is we want to distill the knowledge from a bigger model and create this data set to train a smaller model. So the way it works is we have the first step is to basically use this bigger model to auto-label our data. So if we go to this prediction here, configure prediction, so go to the LLM. So here in this LLM section, you have a choice between different bigger models you can use, like a GPT model or a Gemini model. Those are much bigger model. So let's say we use a Gemini model right now, and we're going to press save here. And then what we're going to do next is we're going to query this bigger model and ask it to label this data for us. So we're going to extract the knowledge from it. So what we can do is press on predict here. And we're going to let the bigger model label this data for us, which a smaller model might have a harder time to do because it has not been trained on this bigger data. So so here the data set, so the labeling has been done. So let's make this bigger. Okay, so as you can see, the bigger model was able to label this data almost correctly. So for example, you have the opening balance. So these are the fields we care about. We want to teach the model on. So we have the opening balance correct. The ending balance was correct. This is different dates, different transaction amount, transaction description, transaction amount, and so on. So, and this is, I believe, the ending balance. Yeah. So here the idea is we collect this data set with some human review. So for example, this might have been missed. So I can simply label this and add it. Let's add this as transaction description. Yeah. So we collect this data set using the bigger model. And then we're going to feed this data set to the smaller model. So if you want to run this auto-labeling on a larger scale, so right now we only labeled one document, but you can actually go here and press and predict all documents. And what this will do is going to browse and select each document here, and it's going to auto-label it. So if I go here, so I already done that, so I'm going to go quickly to show you. So in this case, this is another bank statement that has been auto-labeled. This is another one. It's a little bit blurry. This is another one. So you can always go back here and check, obviously. I mean, the bigger model is not going to be 100% correct, to be honest. That's where the human review is very important. So, but it will save a lot of time in terms of collecting this data set. So after you review this data set, what you can do is you go to the model section here, and then you can press create a new model. And then here, what we're going to focus on, because we're creating named anti-recognition model, so we're going to select named anti-recognition type. And here you can select different type of models you can train. So you have you can train smaller models, like even like a spacey model. So we are distilling the knowledge from a bigger model and training a spacey model. You can use like a BERT model, And you can use another LLM, like a smaller model, like Llama 3.1 or Mistral models and so on. So you can choose any model that you wish here. And then after that, after you select the model, we're going to attach the data set that we created. So this is the data set that we have created, the bank statement data set. So we're going to basically give this data set to that model and train it on. So the end result will look something like this. So let me show you one example. So I already trained the model on this, not specific data set, but I was using invoice data set. So after training, this is what you get. You get the F1 score of that distilled model, the smaller model. You get the precision and the recall of that model. So what this means is basically we do the calculation behind under the hood. So we look at the true positive, the false positives, and then we measure these scores that you see here. So in this case, you get like 71% accuracy. If you want to dig deeper, you can look at the confusion matrix. This is another way of basically quantifying that model that you trained, the distilled model. So what this means is you have on the x-axis, those are the predicted labels from that model that we fine-tuned. And the y-axis, those are the ground truth labels. So anything that's non-diagonal, like this here, number 2, what this means is for this predicted label, it has been predicted as this TTC, which is a tax basically field. But actually the ground truth supposed to be an amount. It's not a tax. It should have been amount before tax. So this has been confused where there's the predicted is different from the ground truth. So this gives you an idea about like how good is your model and how do you improve it, right? So distillation is not just one-time things. I think you have to do it multiple times to make sure that you hit really high accuracy here, like 95% and higher. And with our platform, basically, you can do this iteration over and over again. So if this is not enough right now, like 71% is not good enough, I can go back to the data set. I can add more data set here, and I can auto-label the data set using a bigger model, and then refine-tune it again. So this entire loop can be done multiple times, so you can reach that higher accuracy, model. So we talked about this document extraction. We can also look at another example here, which is information extraction from text. It's the same idea. So we upload, text, any type of text. In this case, I'm uploading like, sentences containing like PIIs, personal identification information, and I would like to create the data set very quickly. So same idea here, press predict, and I let the model label this for me. As you can see, this is a Bitcoin address was correct, the age. So the idea here is like we want to train a model to identify PIIs. So we use the bigger model to basically label the data for us. Same thing here. So the email, first name, last name has been done correctly, and you can always go here and change or improve this labeling. Okay, so now we talked about the information extraction type of distillation. So the second one is text generation, which is like text completion tasks. And so the one I'm going to show right now is for, let's see here. I think I have a data set here. Okay, so okay, this is a data set that I created. So basically the idea is we would like to extract, entities from news headlines. So this is a news headline here and the input text. And we would like to extract the relationship between the entities that we care about. So this is the user prompt. So you can adjust this. But basically what we're telling is like, we care about these type of entities, we care about these type of relationships. Please output a JSON file with entities and relationships from the headline. So this has been created entirely using distillation. So we all we did was uploading this. I will show you in a minute how to do it. Upload the system prompt, the user prompt, the input text, and we should select the model of our choice. In this case, I selected GPT-4o. And then GPT-4o basically created this this output here. And you can do this at scale. So you can run like 1,000 examples or like 10,000 examples, whatever you need. So after fine-tuning, so after using this data set, I fine-tuned a smaller llama model. And so here I'm going to show you what the result is. Let's see here. So this is the model, I believe. I'm going to explain in a minute what this means. But basically, I'm going to show you here just testing the model after fine-tuning. So what you see here, this is the playground where you can test your fine-tuned models. So right now I'm going to test it. So I gave it like a system prompt, a user prompt, and this new news headline. So this was not part of the training data. And I'm asking it, please extract the entities and relationships from this news headline between like different entities. And this is the result here that you see on the right side. As you can see, it was able to extract, the organization, ExxonMobil, the relationship operates in, and this this concept or entity, oil and gas exploration. So the text was saying like ExxonMobil, and their peers are set to cut spending on oil and gas exploration for a 5th year, according to consultancy Wood Mackenzie. Now let's compare this to the untrained model. So I did the same thing, the same system prompt, same user prompt, same input, and this is the output of the untrained model. It looks pretty good. Like the structure seems fine. There is a lot of redundant entities. For example, ExxonMobil has been shown like 3 times, like cut spending and cut investment. If you compare to this, there's only one. Because it's the same concept. There's no point of doing it multiple times. And most importantly, if you look at this at the bottom, which is very interesting, it's saying ExxonMobil operates in Wood Mackenzie, which doesn't make any sense. So Wood Mackenzie is a consultancy company, and ExxonMobil does not work for Wood Mackenzie. So this is not good, right? This is like untrained. And if you look at our trained model, you don't see that. So it says like Wood Mackenzie, announce spending cut, which is correct, has a negative impact, cut spending and so on. So this is like more concise, less redundant, I would say, and more accurate if you compare to this to the untrained model. Now this qualitatively that looks good, right? But I think what's very important here is we have to do statistical analysis to know how good is our distilled model. And this is where the metrics, the evaluation comes in. So if you go back here, after fine-tuning this model, you can see this metric called Rouge L. What this does is basically it looks at the output of the model, and then it compares that to the ground truth and see the overlap, measure the the overlap between the words, if they are identical or not. And you can do it on like n-grams, like measure like 2 words overlap, or you can do like L, like the longest sequence of words in the output. So what this tells you is like it's 42% overlapping to the ground truth. That means the output of this model is 42% similar to the training data. No, sorry, not the training data, to the ground truth data that we got from the distilled model. So obviously you want this to be higher, but this metrics allows you to kind of quantify how good is your distillation. Do you need to go more? Do you need to create more data to get this higher and higher? So it's really, really important to not just distill once, but like keep monitoring and evaluating that model performance over time. Yeah, so basically, as you can see here, like qualitatively, it looks better, but I think it's better to look at quantitatively, like what is the metrics. If you guys have any questions, please interrupt me anytime. Happy to answer any questions. Okay, so the next type of data set, let's do one distillation. Let's just do one example. So I'm gonna create a new data set right now. Let's select the prompt and response data set. This is basically for text completion tasks. So I'm gonna like that. We're gonna press generate dataset. Let's give it a name. I'm gonna do this on fraud detection. So I'm gonna do fraud detection dataset. I'm gonna give it select the language, press next. Don't worry about the variables. This is not important. I'm gonna press next. And right now, what I'm gonna do is I'm gonna upload a CSV file that has like a system prompt, a user prompt, and an input. So the CSV file will look something like, I'm not sure if I have it here. Will look something like this. This is not important. So the CSV file will have like a user input. In this case, what we're doing, we're gonna provide transaction payment data, like transaction data to the model. So we're gonna give it this transaction JSON, with the transaction type, all the details. We're gonna give it a system prompt and a user prompt. And so we're gonna go here and upload the CSV file. So let's upload this file. This is the one, I think, reasoning dataset. Let me double check, just 1 moment. Okay, it looks like it's already open. Let me just double check it here. Yeah, so this is the file. Okay, so let's go ahead and upload this file quickly. Open. So as soon as you press open, it will ask you to map the user prompt. So we're gonna map the user prompt here. This is the name of the column. The system prompt, I'm gonna use this. And the input, this will be the user input. And here, what's very important is we're gonna select the model, the big model, the bigger LLMs that you wanna distill the knowledge from. So we're gonna click on this model section here. And then here you can see a bunch of models. Those are previous model I trained. So if you haven't trained any model yet, you will only find these models at the bottom. So here you can select a GPT-4o model to generate this data set. Let's select DeepSeek model. So we're going to do DeepSeek R1 distill Llama 7TB. Let's do temperature, I don't know, like 0.6 or something. No, it doesn't. Okay. And let's press generate. So now what we're doing is we are feeding the user prompt, the system prompt, and the input to DeepSeek, and we are going to get the output back. And the idea is we're going to use this output to basically fine-tune a model with. All right. I think it's done. It's just like getting confused because I have too many tabs open here. Okay, I think it's this one. No? Yeah, I think it's this one. Sorry, not this one. Go back here. Just 1 moment. Okay, so let's open this. It's already done. Let's open this one. Okay, so this is what we get. So basically, we gave the file give the data to DeepSeek, and we got the output back. So this is the output that we get is reasoning steps and the answer at the end. So we have the system prompt, the user prompt, and the input text. And also at the end, we have this, the output is basically the output from DeepSeek. So as you can see, it's known like here, to show like, thinking steps here. So we have it's thinking and doing all these things. And then at the end, it determined that this transaction is not fraudulent based on all these thinking steps. So what we do next is we collect this data set. Right now, I only have 2 data sets here, but I have already fine-tuned the model with this. So if I go to credit card transaction, so I tried with 500 examples of distilled data set. So I have 500 examples here. And the next thing to do is we're going to fine tune the llama model with this. So we're going to create new model. We're going to select, in this case, we're going to select text generation, and we're going to give it a name. Let's say fraud detection llama. And we're going to select, let's go ahead and select llama 8 billion parameter. And then let's select the data set. So we're going to assign a data set. It's called credit card transaction, I think. I think it's this one here. We're going to press finish. So right now we're ready to go. I only have like 2 rows. Obviously, it's not going to do anything, but just want to show you kind of the flow. So we have the data set available, and then now all we have to do is simply, go and train the model. And I already trained this model. So if you go back here, 8 billion parameter model. So this model has been trained on the thinking steps of the DeepSeek model, and has been fine-tuned on that. So the score is pretty low, actually. That means the 500 data set is probably not enough. And in this case, I might need to generate more data set for this. But the idea is you can generate this on demand. It's actually not that hard to do. So all we have to do is simply generate new response, and then add your CSV file again with more examples, and then choose the model of your choice, and then go back here and retrain the model. You can press on this retrain model here. But I think the important aspect, the important thing to think about is we really have to evaluate the model afterwards. We don't know beforehand if 500 is enough, or 1,000 is enough, or 10,000 is enough. You will need to evaluate this and make sure the accuracy on that specific task is what it basically reaches your requirement, or satisfies your requirement. Yeah, so basically, one more thing here just want to mention is after you train the model, and let's say you reach really high accuracy, you can use this model directly. So if you click on code here, you can copy paste this API code into your application, and then use this model directly into your application. So we kind of abstract all the complexity, so you don't have to worry about putting the model in or serving the model in your server. You can simply call it with an API. If you do want to, for example, run this model locally, let's say for privacy reasons, or you want to run it on your phone or something, you can always go here and press download. So right now this one is, I think, it's not open, but if you go to a different model, you should see download model here. So you can press download here. And then you can download the weights of the model and then run that into your application. So yeah, so that's basically the idea. Yeah, so basically, I recommend everybody to play around with this. I have a bunch of models I've trained here for patent claim generation, which is really cool. This one is I trained it on a data set to generate patents, descriptions, which was really cool. And it actually works really well. You can do a lot of things, right? You can fine tune on chatbot, like conversation, mathematical problems, and then basically serve these models, these smaller models, into your application. Perfect. I think we're done with the demo. Are there any questions? You guys still hear me? All right. So no question today. One last thing before we go. I know we have 15 minutes left. Just the takeaway, right? What's really important is to remember, a few things that you have to remember after this talk, is the knowledge distillation is really a great way to build really highly accurate and cost-effective and private task-specific LLMs, or small LLMs. Evaluation is so important, and having that loop of evaluating the model and improving and continuously improve it over time is super important. So that's the second point. And the third point is human in the loop is still very, very important. So the this whole process cannot run autonomously yet. So you still need a human in the loop to review the data, make sure it's output the right information correctly, and then use that high quality data set to fine tune your model. So those are the three, I think, takeaways from this talk. Second is we have a Discord community we just started. So please, if you would like, please join our Discord community. If you have any questions, or if you have a specific project you want to discuss, we'll be very happy to do it. So this is the link here, and we're going to send you this presentation after this talk. So yeah, please join. We can have a discussion and discuss more about your project and the specificity of your project. And finally, if you would like to speak in this webinar, so we're looking for speakers. So please send me an email at this email address, and we'll be happy to arrange like a speaking slot for the next webinar. And that's it, unless you guys have any questions. Okay, so I see a bunch of questions here. So Ruslan was saying, how does the teacher model reject unwanted data towards the student model? So yeah, so basically this is I think you're referring to the reinforcement learning. So that's basically based on the prompt that you give to the teacher model. And we have it actually here. So we have this LLM monitoring, or LLM as a judge. So if you go to LLM evaluation setting, you can select your LLM of choice. Looks like my LLM is not set up here for some reason. Okay, so you select your LLM of choice, like Gemini, for example. And then you can add these evaluation templates. So you can, for example, let's say you want to reject or approve based on a specific metric, like hallucination. So you can like create this like hallucination, template. You can give it, for example, like a prompt with maybe a few examples of what should be good, what should be bad. And then you can give it like the output, expected output, like correct, incorrect, hallucinate, not hallucinated, maybe a score from 0 to 5. So you can basically prompt this bigger model for a specific evaluation metric. So it doesn't do it by itself. It has to be guided exactly what to look for. Yeah. So is there a way to input Anthropic Claude 3.7 model into okay, so right now we have GPT supported. We have also Gemini, but we will add Claude soon. Yeah. So expect it to be added very, very soon, next week or so. That's an actually pretty easy thing to do. So another question is there a mechanism or function that can automatically summarize which document have been completely labeled? Right. Or function that can automatically summarize which document have been completely labeled. Okay, so I think what you mean is when you label the data, is there a way to evaluate the auto-labeling automatically? And yeah, we don't have it currently, but I think it's possible. So you could, in principle, send this data here. Sorry, yeah, send the data here with the labels to maybe another LLM and ask it questions. It's like, is this completely labeled? Does it cover all the aspects? So you can add another judge here in the loop. So in principle, it could be done. Yeah. Okay. Oh, I mean the extraction. So like, if it's possible to evaluate if the extraction is correct or not. I think it's still possible. Yeah, I haven't done it personally, but I think it's something that's possible to do, to play with for sure. Do you have other question? Push one. Okay, you're good. Okay. Any other questions so far? No questions. Okay. If you guys have any questions, please send me an email. On Discord, or like by email directly to me. I'll be very happy to answer them. If you would like to try the platform, it's free, so please try it out.